Hello everyone. Welcome back to my channel. Today, we will dive into the fascinating world of full adders. If you're new here, consider subscribing and hitting that notification bell so you won't miss any of our future tech tutorials. Now, let's explore the ins and outs of full adders. Before we jump into the technical aspects, let's understand what a full adder is. In digital electronics, a full adder is a combinational logic circuit used to perform binary addition of three single-bit inputs, A, B, and the carry-in. It produces two outputs, the sum and the carryout. To grasp the internal structure of a full adder, let's take a look at its schematic diagram. As you can see in the diagram, a full adder is constructed using XOR, exclusive OR, and AND gates. The three inputs A, B, and CIN are fed into these gates, which then generate the sum and carryout outputs. Let's understand the behavior of a full adder with its truth table. The truth table displays all possible combinations of the three inputs, A, B, and CIN, and their corresponding outputs, sum and cout. Understanding this table is crucial as it forms the basis for building the Verilog code. From the truth table, using K-maps we can deduct the equations for the sum and carryout outputs. The sum is equal to a XOR B XOR CIN. The carryout is equal to A and B or CIN and a XOR B. Now, let's write the Verilog code for a full adder. In this Verilog code, we define a module full adder with inputs A, B, and CIN, and outputs sum and cout. The internal logic implements the XOR and AND operations as seen in the schematic diagram. Verilog is a hardware description language that allows us to describe the behavior of digital circuits. To ensure our full adder is functioning correctly, we need a testbench to simulate its behavior. The testbench code is used to apply different input combinations to the full adder and observe the outputs. This way, we can verify if our full adder is performing as expected. It's time for the exciting part, the simulation of our full adder. Open the terminal and follow the instructions on the screen to open gtkwave. After opening gtkwave, go to File, open New tab, and open the full adder VCD file. After appending all the inputs and outputs, let us observe the waveform. Zero plus 0 gives us a sum of 0 and carry out 0. Zero plus 1 gives us a sum of 0 and carry out of 1. One plus 1 gives us a sum of 1 and carry out 1. As you can see in the simulation, we've tested various input scenarios, and the outputs are in accordance with the truth table we discussed earlier. This confirms that our full adder is functioning correctly. That's it for today's tutorial on full adders. We hope you found this explanation valuable and insightful. If you have any questions or want us to cover more topics related to digital electronics or Verilog programming, feel free to leave a comment below. Don't forget to like this video if you enjoyed it and share it with your friends. Thanks for watching, and we'll see you in the next video.